6:33. Okay, I think we can get started, and we will see how far we go. Today is not too big, so we might just finish in time for change. Cool. So welcome, guys. Thanks for joining on this Christmas week. Today we are going to learn about Python serialization, and this is a very interesting topic if you are into inter-system communications, because this the concept of serialization comes when you are building a system which is talking to each other, or uh, you know um, uh, often and not, if you have to store some data that is not into database, then serialization can come handy as an alternative to plain file storage. So let's dive in. Okay. So what is serialization basically? What is a serialization mean basically? So serialization is a way to converting your data structure or data, anything, uh, into byte format basically, and in a way that it can be recovered back into the same data structure it used to be. That means, let's say, you have a dictionary, you have, let's say, list, or you have created some custom Python object. You have this weird class that you have created, my class, and it has all methods and parameters and attributes, and you are creating different object out of that class. Now there is also data, and uh, when you want to send that particular structure over the internet, let's say you have two Python services that they talk to each other. You want to send data to each other, or you just want to store that data into your file system. uh, Serialization is the best way to do that, because uh, basically we are storing those data into the byte format, and the byte format is something that computer understand very well. So it often serves well when you want to transfer data over the network, or as well as when you want to read something. Uh, it get your job much more easier that way. Uh, so uh, so just to understand, just to baseline, what serialization basically is you have some data structure, you have some data in whatever language, and when you want to store them or transfer them, basically by putting data into serialization process, serialization is a process where you pump in data and it come out as a byte objects, and then you can use those byte objects to transfer over the network, or just store them over the local file system. So that's what the serialization basically means, that we convert them into byte data. So this is something look like, you have Python object, and we'll talk about pickle and pickling. Pickle is one of the way to do the serialization. There are multiple ways you can do serialization, because you can think of serialization also as an encoding decoding process, where you have this Python data, you want to encode them into byte objects, and then you're going to decode them from byte objects to actual Python object back. So this is what basically serialization look like. You have Python objects, and you are converting them into the sequence of zeros and ones, basically bytes. That is block of 8 bits, or 801s as you call it, byte. Now, why do we actually need serialization? Uh, so what purpose it serves basically? And so first thing is, let's say you have some data, you have some state of objects. Let's say you have this data which is passing through multiple pipeline or multiple stages, where the object it start with, let's say it has 5 attributes, and over the time the value of those attributes change. So let's say if you want to save them, let's say you want to do checkpointing on those objects, you need to store the object, and you can use serialization to store the objects. And when you want to recreate them, you can recreate them directly. So it make life easy when you are recreating object after storing them, because think about it. Let's say if I give you some kind of dictionary object, or some kind of class object. You have this typical like my car class, and uh, you want to store that object, you want to store that object of a my car. How would you do that? Like, the most if you, so you can say that, hey, if I want to store my car, I can either store into database or into file. So if I think about storing into database, then I have to create a whole database, tables and everything, and then convert my object into tabular format and store into database. Second way I can do that is, take the data and convert it to some kind of typical CSV or JSON kind of format, and then finally store them as a plain file object into table. Now, the problem with that is, sometimes it become more complex to design such thing. So think about it, like if you have to design separate database to maintain the state of the object, it's just way too complicated for the, and database is not designed to store the state of the objects basically. uh, and when you talk about the file system, so reading and writing the file and converting them into one format or another format is not easy task, and not easy in terms of just the extra line of code, but also the time it takes to basically convert your object into file and file to object. You basically have to return the idea that if I have certain object with a certain state, when I say object, let's say it's a class object, and it has let's say 5 methods and other variables, and each of them has different values. So uh, if you want to store a big class object into file, so you have to like literally write the code which capture everything, and how you want to store the data into the file in which format, and that may get some complicated. Now imagine if you can take the object, store them as it is, and return them as it is. Technically, you have this variable name called my object, my car object. You can just throw them to, hey, store this my object as it is into the file, and when you read it back, it came as a Python object itself. Literally, like you store the Python object and you read the Python object. There's no conversion going on. You are not doing any CSV conversion. You are not changing or putting your object into some other kind of format. You are just literally taking the Python object, putting it into you're saving the object inside the storage, and then reading them as it is, and go and keep going with your life. Like how easy that would make. You don't have to worry about designing any other kind of database. You don't have to worry about storing with the file. All that can be go away. So with the serialization, you can save the state of the object and recreate it as you want, and um, and that is very useful. So it also make very useful when you're transferring data over the network, because let's say you have two services that need to talk with each other. How would you do that? You are basically going to, like, so one of the object is either you can have a client server who can do HTTP or REST design, where they communicate via HTTP server. Now HTTP is but imagine you're not sending small data. Imagine if you're to send a huge amount of data, then using HTTP to bring it to some kind of JSON or other format will be very hard to uh, compress and send it over, uh, and it will have its own complexity when you're transferring the literal JSON, the huge, let's say 1 GB of JSON data or 1 GB of CSV file over the network. And that's not going to make a lot of sense when and this is not about client interactions. This is more about, let's say you are building a distributed system, and you are trying to break down your data and storing them in different pieces. If you heard of Hadoop, the distributed framework, that is how it works. It basically, you have, let's say if you throw 2 GB file into Hadoop distributed system, it basically break the whole file down into multiple chunks, and then distribute multiple chunks into multiple boxes, multiple storage data, multiple server. And and when you have this kind of communication going on internally, RESTful API won't cut it. You need to have something that is faster, something that is reliable, and guaranteed the the end-to-end delivery of the whole file. So when you have those kind of complex scenarios, a normal RESTful API will not do the job. So when you want to transfer huge data over the network, you need to have some kind of serialization that will help you to transfer data over the network. And And that's where serialization come into picture to help you with the transferring huge amount of data consistent faster. And same with the storage also. So as I was talking that, you know, if you were to think about storing files, storing object into file or database, it will just take a lot of time. But if you just store them, if you serialize them and store them into file system and just read them as it is, it's going to be very, very faster. Uh, so for all those reasons, for faster, you know, for the storage, reading, writing, and transfer the network, you know, serialization is preferred way to go for. And again, so it just you're taking the object, big object, and converting them to bytes array, and then communicating using that. Now, how to serialize? So this is basically what are the ways you can serialize your data. When I saying like we learned that, hey, we need to serialize data because you know, we need to transfer them over the network, or we need to store them for the checkpointing purpose, or some other reason. Uh, so Json and Pickle, these two are right now most popular framework within the Python world. Json probably is even popular like all across the other programming languages uh, for storage as well as for the transferring of data. Pickle is very Python specific. That means this is not available anywhere else, and uh, and it has its own perks, and its own issues. XML is probably predecessor of JSON. Right now, JSON is very popular, and I think in early 20s, XML was very popular way to do the uh, data transfer, external data transfer. Protobuf is something came out of Google, and they use it a lot in the internal distributed system, where when they are storing huge chunks of data between different computers, Protobuf is the way how the message is being communicated within the whole distributed system, either data or messages. So they use Protobuf for the reason that it's so faster and much more reliable. And then there's a message pack. There is also something for the Python, uh, and yeah, we won't look into too much of that. So for the demo purpose and for this presentation, we'll only look into JSON and Pickle, and very small example, introductory example, but I mean to convey why they are important and one was the other. Second thing about serialization is external API and internal communication. So the idea is when you are thinking about serialization, like, so how you have these so many formats. So how you choose which serialization format you need for a particular use case. And when we are talking about the communication between different systems, there are two kinds of communication we can think of. First is communication between intersystems. So classical example, any kind of distributed system, any kind of internal microservice framework that you might have, where you are writing different Python services which are talking to each other. Uh, that is an example of something that require internal communications. And external communications, when you are trying to talk to different systems or something that is outside your software, your Python framework, whatever you're trying to build. You want some other kind of clients to talk to your framework. You can so that might be one of the reason. That kind of communication is one of the communication for which you might need serialization. Just give me a sec, let me get some water. My throat is drying. It's coming in the way of my talking. Give me 5 minutes. Sorry, I might sound better now. My throat was drying, so I couldn't speak properly. But I think I will try to speak much more clear now. Okay, cool. So we were talking about serialization and which kind of serialization we want to pick, which kind of technique of serialization we want to do, and it majorly depends on whether you are building a system or that is for external communications or internal communications. We touched on what internal communication look like, where you have built multiple Python processes that want to talk to each other. That is the internal communications, and let's say you're building some kind of APIs. So external system can talk to your system, and you want to transfer data, faster. So that is where something you can provide the serialization, or you can do the serialize of the data. Now let's talk about the JSON. I'm gonna like really it's a really simple selection. JSON is basically it's very popular format, and today a lot of APIs and lot of inter-system communications use JSON as a standard format. Uh, JSON is standard format. That means it is being implemented and understood by different systems. That means let's say if you want to talk to if you have a Python system that want to talk to Java system and you want some kind of common language, JSON could be that common language, because JSON is a standardization, it's a standards, and Python and Java implement same standards. That means they have same common language. So even though Java has its own JSON package to encode things into JSON, Python may have its own package to encode data into JSON. But when after the output, both can talk to each other, because it's the same language. So it's easy to talk to different systems because they both understand this common language. So it's easy to work with multiple systems, and there are so many widely available systems out there that use JSON. So when you're thinking about serializing your data, that data is meant to talk to external system, you can use JSON and tell that, hey, you can have the data from my system, and the data will be serialized with the JSON. And so since JSON is very standard format, any system will have some kind of a JSON implementation. If you are using Java or Rust or C++ or Ruby or any other language out there, all of them will have a way to read the JSON serialized data. So that's why it's very useful. Now some cons. So because it is a open standard, that means everything that participate in JSON serialization has to be commonly understood data types. So when you are trying to introduce some kind of complex data types that is not well defined within different programming language, it can be difficult to convert. So imagine that if you have an integer into Python, the same integer could be easily translated to integer of Java or integer into C++, both, because all of them has similar kind of ideas. But not all language has common date time. Date time is very classic example, because date time we use a lot into Python, and date time is something that is not easily available in other languages, and they don't have, and there is no standard date time in every other language. So when you have Python object which is date time, it will be hard to translate that to other language. So sometimes JSON fails basically in serializing object when the things that are you trying to serialize with JSON are not standard or standard kind of data type or standard objects. So JSON work flawlessly if you're string, if you're integer, if you're float, if you're list, all that kind of stuff. But it can break when you're trying to encode something for the date time. So that is the con. That so for other reason, JSON is used widely for external communications and not so much for internal communication. So because date time timestamp is very sometimes used for internal communications, and uh, JSON is not good for that. So that's one of the serializing platform that we have. The second one is Pickle. Those who are working with the Python a lot will be very familiar with the Pickle. Now, Pickle is very Python specific. That means if you serialize something using Pickle in Python, you cannot deserialize that into any other programming language. So if you have pickled Python file, you cannot get that file be read by either Java or any other programming language. You can do with the JSON. If you have JSON byte format file being stored, Java can read that file, even though it was created by JSON, created by Python, sorry, because uh, Python is creating the serialized format that is commonly known to every other language. So you can create a JSON file using Python, and that can be read by Java. It will work flawlessly. But Pickle is not the case, because Pickle is specifically designed for Python. So something that is serialized in Pickle will not be able to read by any other programming language. Now, the advantage of Pickle is Pickle serialize all kind of things, like it can serialize socket objects, it can serialize all kind of object that you can think of in general. You can serialize all kind of custom classes, and it's very easy to use. And Pickle is being used a lot in the Python world, where let's say you want to store some state of data or files, and then you want to read them into future, and you don't have to go through the same problem that I discussed before, like you don't have to create a database to store them. You don't have to create the a file format to store them. You can just take Python object as it is, store them into your data as a file into your file system, and then you can just read them. It will read out of as just as any other Python object, and you can go with that. Now Pickle has some restrictions. So if you're familiar with the lambda expression and generators in Python, so for some reason Pickle still does not support serializing lambda expressions in generators. So you must be knowing that Python is Python consider functional programming language, and Python does support functional programming language, because all the functions and methods are considered first class citizens. That means all the functions are basically objects, and that means they have their own methods and everything, and you can basically pass a function as a parameter into another function. So that is one of the reasons why it's a first class citizen. In Java, you can't do that, at least not until Java 6, 7. I think now they have some functional element, but older Java, you cannot pass any one Java method as a parameter to another Java method, but in Python you can do that. So that is something is the capabilities a programming language have when it is a functional programming language, and Python can do that. Now, lambda expressions are kind of inline functions, and they can be treated as an object, but still, for some reason, it is not being able to pickled. And same for the generators. Generators are also a kind of a method that that generates data basically based on defined rules. So this is the restriction right now currently. Even though Pickle can serialize objects such as socket readers and file handlers and all those kind of weird things that you can think of, all the network communication objects that it can pickle. So these are two major things that we'll look into, and let's go to the code. So first thing, so how to deal with JSON. So as always, you first import the JSON, and now for the example, we have one JSON object here. This is Python list basically, and to convert into byte array, we first need to convert into the string. Now JSON has something called JSON.dumps, which will basically convert any object, this is a list, so basically convert into string.
Nishant, I don't think you're sharing your screen.
Oh, sorry. Wait. Let me try it again. Basically, thank you for pointing it out. Oh, I think I only said my. Okay. Can you guys see my?
See it now.
Okay. Thank you. I can't miss. So. Okay. So starting with JSON, let's talk about how we can deal with the JSON object. So first thing, import JSON. JSON is a very powerful library. It has so many other functions that you can do with. First thing is, this is our data. So we are starting with a simple list, and 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 what we're going to do is that we're going to use json.dump to basically encode as a JSON string. So this is how it looks like. So this is our encoded data. Type as str. Now, with once you have a string, you can basically do the string dot encoding, and you will get the byte data. So because this is a Python 3, you can see this b as a byte type. So this is another new data type introduced in Python 3. If you're on Python 2, you may see something else. Uh, and so now, so if you can see here, this was a list, and basically we convert it to byte data, and to convert it back, as you said, that serialized data can be converted and converted back. So from byte to again list. So what you can use is something called json.loads that will take a JSON string, a byte JSON string, and basically convert into the actual object. So this is what JSON serialization look like. Uh, Now let's take this example which I was talking about, where JSON fails basically. Um, so date time is one of the classical example where it fails. So we are importing date time, and here I'm trying to create a data object. This is a dictionary. We have two keys here, two object in a dictionary, and second has date.today. So this is our object, and when we try to basically do serialize using json.dumps, we basically get this error that at the end object of a type date is not JSON serializable. So the idea is that there are some types which JSON will not be able to serialize, and date time is one of them. So this is one of the restrictions or limitation on JSON here. Okay, now let's talk about Pickle. Pickle is another as we talk about, it's a Python specific another serializing library, and very similar. Pickle also has Pickle dumps, and this will take. So right now, our example, we are taking this a Python list as a Python object, and this will create a Pickle string. So as you can see, these are, because Pickle is Python specific. So the internal conversion is something which is not very readable. So you can see this kind of like byte string, hexadecimal um, format data, and so this is how the Pickle string gonna look like when you load them. And so this is how you basically convert into pickle data, and then same as json.loads, we can also do pickle.loads and put in the serialized string to deserialize them, and we get our object back. Uh, let's look at some more complex example. Not complex, but slightly, more extended version. So we have data, and A and B. You can see they are also dictionary. And the normally, when you're creating pickle object, you're not just creating them. You're basically storing them and reading them. So what in here in this example, what we're gonna do is we're gonna create a file called mypickledata.pickle, and store our data into pickle format, and then again read them. So if you can see here, with open mypickle.pickle, this is write and this is byte, so that means write into byte format as out, and then this is a standard way to open a file into write mode, and then we say that pickle.dump data and out. So this is our file handler, and this is our data, and we basically we can load the file, and no, it was not has. And if you can see here, this is a file that is in current directory being uh, being posted. I'm running. So this is how you run Linux command or terminal command into directly from your Jupyter notebook. So exclamation mark and then command. So it will look something like that, because it's not readable basically, this file, all weird object anyways. Now we can read the same thing, read byte, and pickle dot load, same thing, and we can load the data and we can see the data being reconstructed as it is. Now, let me talk about a couple of examples where we used pickle in our data robot. So, uh, we data robot as a company who has a software, enterprise software for data science, machine learning, and we also deal with a lot of datas. And more than often, let's say customer asks that, hey, you have this model, take this whole bunch of data and do the predictions on all this data and give us the result. Now we are talking about all this, like, this is async operation. So basically, once you submit the data, we say that, hey, we took your request, we're going to process your result, and then we're going to tell you when the computation is done. And now that computation is done, you have, let's say, 1 GB output data that you want to send it forward. Now this 1 GB output data, because you're dealing with the data, normally they're often into NumPy or Pandas format, because NumPy and Panda is in which we normally, deal with the data. Now, how do you send that 1 GB data, which is into Pandas to the customer, basically? So, so first thing, once you are done with the computing, you have to store the data, right? So you have computed 1 GB of data, all this data, you have to store them. And you think that, hey, like, you can just store them into some kind of CSV file. Pandas is, tabular data structure. So you can, of course, save the whole thing simply as a panda.csv, and you can store them. And that is a valid point, that you can always store the data easily into the file system. But think about it, when customer make a request to, hey, get me the data, you have to read the data. And here is when the trick comes in. So customer can say that, give me the data in either JSON format or as a CSV format, or give me the file itself. So either they're asking data into the in the response object itself as a, as a HTTP response format. So data is traveling as a response object, or they can say that, give me the whole file. So you remember when you click on download button, how the whole file get downloaded. So they can say that, give me the whole data either in that, download file option, or give me the data where I can see the data and I can, like, it's not in a file, it's coming directly on the browser, it's coming directly into my object, it's not a file. So customer is asking this huge amount of data into multiple format, basically. Yeah. So what you can do about that? So if you're just storing it as a plain file, let's say CSV, so if customer asks as a plain file, you can just directly give the file. But if customer is asking that file as a, let's say, JSON, so you have to read the whole file. And when you're reading the file, you're basically taking the file as a CSV and then loading them into Python pandas, indexing them, doing all that. After loading the whole data into pandas, which is again, which is not easy task. I mean, which will take some time. Then you have to reformat the data, and then you reformat the data, and then you send the data back. So if you end up storing your data either into one solid format that is not pickled, that is, let's say, a plain CSV format, or a plain JSON format, not a JSON serialized, but more like a, just a JSON data. Uh, reading and writing, reading the file and processing them and sending them will take a lot of time. So we have to come up with the result where we can save some time while building the response. So what we did was started storing the whole object as a pickle object. That means uh, when customer is asking for results, or, hey, give me that computed data, that I requested for, we just go and read the pickle data. We just read the pickled file. And because pickle file is basically, as you read the pickle file, it's just going to load as a Python object. So we're going to retrieve the Python panda as it is when we store them into memory. And once we have them as a Python object, then we can do the formatting and give it back in the way customer responded. So the whole, that small conversion of reading the data from memory into, like, one format to other format, CSV to pandas format, we can save that time. And again, distribute the data. So you will see so many scenarios of that kind of search, where you want to preserve state of your state of the object, state of the memory, and then you want to like reload the whole thing without creating any intermediate storage format. So when I have data into pandas, and when I'm let's say storing them into a CSV file, I might have done some custom indexing on pandas, because panda, you can say panda can have two level indexing on row and column level. I can you can either you can do a simple indexing or you can do custom indexing. And when I'm storing the data as a CSV file, I might lose on those extra formatting that I might have done in order to process the data. So the idea is, when you have data in one format, and when you convert it into another format, it sometimes lose some element, and when you're trying to retrieve it back into the same format, it might not be the exactly same. It might be similar but not exactly same, because there are some corners of information that you miss when you do the format transfer. But when you are doing serialization, so in the serialization, you don't really you're trying to preserve the actual uh, format of the data. So you hardly lose data basically. So when you're doing Python pickling, so you, because you are retrieving the panda object as it is, all these extra changes that you might have done on top of the actual data inside the panda, you can all preserve that and use that. And that is sometimes very useful. I can also talk about Protobuf. So one of the reasons that, as I was talking, that communication is the most expensive thing in the when you have multiple system which has to achieve something. And computation is faster. If you want to compute something, it's a faster. The most slowest thing into any computer system, any computer architecture, is the communications, because your data processing, your CPUs are working on gigahertz speed, gigahertz per, Pentium, Pentium 7 3.4 gigahertz. That's the quad size. So that is the frequency at which your signal do the processing. And with that, basically, you are executing more and more instructions. So your CPU is very very faster. Your memory is kind of slower, because uh, um, because it has to come to CPU to do processing. But your network is the most slowest part of your whole system, because data traveling through cable or data traveling through either internet or network is the slowest piece of uh, communications. Slowest piece, the most slow thing in your whole system. And to achieve things faster, you have to make this faster. And serialization is one of the way to make this communication faster. And Protobuf is one of those ideas, like how we can make inter-system communication a lot more faster. So what they do is, they basically predefine some kind of format for system, like this is the schema on which we want to communicate, and they are pre-compiled. So when they communicate, it's there. There's no, they don't check. There's all, pre-checking of schema. There's no, so many other pre-processing is done already. So when they are communicating, there's a least amount of pre-processing and post-processing happening when you are trying to communicate when you're using Protobuf as a communication or a serialization mechanism while you are transferring data over the network. So serialization is basically, it's all about how to reliably and fastly you can do inter-process communications, and store and retrieve the data in a very very faster manner. And when you are working in the Python, pickle is one of the great example. Now one challenge you might find with the pickle, so let's say you are building let's say software system like a data robot. This is one problem that we faced. So let's say with using this system, we were using pickle version, let's say 1.2.5. So pickle 1.2.5 may use some kind of standards and some kind of libraries. Now when you pickle them, basically, so you store the state. Now let's say over the time you don't use that file, and over the time you change your pickle versions, you change the other dependent library that were used in that object to pickle them. So over the time, uh, when all those pickling system change, so basically your serialization system change, and the data that has been pickled or serialized before, uh, when you try to read them, you may not be able to read them properly, because of something we can call backward compatibility. that the file, the pickle, the encryption, the encoding that you did was in the older standards, and now you have changed the standards, and in the new standards it cannot read the old standards. So that is the one problem with pickling, or because pickling is this may not happen with the JSON, because JSON is much more open and standardized format, but pickle is very Python specific, and as you change your system, as you're using different kind of libraries into the pickle, it may create some kind of problem. Because with the pickle, so let's say you were using Python 2 pickle. Now you change your system to work for Python 3 itself. And that actually came up with our internal Python 2 to Python 3 conversion project, where we had all this file being pickled with Python 2, and we changed to Python 3, and now we have to read those file into Python 3 pickle implementations. And there's always those small corner cases where things may not work, and your pickle file, you can't read the file properly, and it may cause some problems. So these are some issues with this kind of serialization, that when you're serializing something one time, and when you're trying to uh, you know um, upgrade your system, you're pickling methodology, or let's say you use some older version of some library while pickling the file. Let's say you are using the third-party library, and when you pickle that thing, the third-party library object that you used was older, and now that you have upgraded all these libraries and your systems and everything to work with the newer third-party library, and you try to read the pickle file which was built with the old third-party library. So those kind of thing can cause a problem. So that is something become challenging with the pickles. Now this is something doesn't come with the JSON, because JSON doesn't let you do a lot of those kind of things where things are not predefined, or things are like custom and third-party libraries and stuff, and uh, JSON just can't serialize them. So it doesn't start with that. But because pickle serialize them, it may cause a problem when unserializing or deserializing. So that is something you need to be careful about. Uh, I think with that, I would like to stop this session, and uh, if you have some more questions, we can talk about that right now. Mm, Does any of you guys have used any kind of pickling before, or any kind of serializing before, any kind of system where you had to do this kind of things?
Well, I've done. I've used Pickle to save, um, basically a dictionary. So now that I'm thinking about it, I probably could just use JSON and dump S, so that would make it more flexible. I was wondering if you had any issues with any, like, I guess, size limitations with Pickle. Because I feel like I've tried to load something that was very, like, a huge data, and I think it ended up crashing.
Honestly, so as I told you the example, this is a real example, something that we worked on, and we never actually faced any problem with because technically when you know when you're writing the file and reading the file, so first limitation may come from file system itself. You know, but I think that should not be a problem. Like, it's not going to be like huge GB of file, 50 GB file that your operating system cannot handle. I don't think that should be the problem. Second is the RAM. Like, let's say you create the pickle in, let's say, larger or bigger system, then you move to smaller system and try to, like, let's say, depickle them, and your other system may not be able to handle that much memory. Uh, because it's all about, so it's everything is going to stay into Python memory block. Uh, you know, uh, Basically Python service or Python program. If your Python program cannot handle that much data to load with, that is where it can cause a problem, I think. I cannot think of, I we personally haven't faced any of those problems where it was a memory issue that led to issue with pickling or serializing. So maybe no, my answer is I haven't seen any problem like that. Good. Okay. Anyone else? Any other questions? By the way, so I have a small good news for the whole team. So InterSystems, I don't know if you guys know this company called InterSystems. They have a huge office right up Microsoft Nerd Center, Cambridge, next to MIT, and they are largest yeah, electronic health record system. So if you know about all these many EHR system companies, they are basically providing all the backbone of the system. It's a very old company that hasn't been quite famous around here. Like not a lot of people know about InterSystem, even though they are providing the backend for a lot of these EHR big EHR systems, and they decided to be our sponsors. That means so they're ready to sponsor venue. We can go in we can do our events at their office, also food and coffee and everything. And they are also happy to do the food delivery while remote meetups. So basically we can all sit on our couch and we can have some food delivered by them, just to be be on the event and like come here and like talk. So this is something coming up, and I might have someone from InterSystem come next month on our meetup, and probably talk about something about the company. But the idea is that, yeah, this is what the recent change, that now we have a official sponsor, and they'll be happy to sponsor for whatever we want to do during our meetup. And food and venue is kind of like most typical thing, but yeah. Um, cool. So let's see. For the January meetup, I'll try to see what we can do, and if we can deliver some food or something, maybe a Starbucks coffee or something for all of us while sitting remote, Grubhub or something for all of us. I'll let you know about the logistic, but yeah. Okay.
Cool.
Cool.
Thanks, Nishant.
Thanks, guys. So have a happy holidays, have
Happy
a
holidays.
Christmas, and I'll see you next month.
Yeah,
Bye,
thank you.
guys.
Sounds good. Bye.
Thank you. Bye.